remember last time we did partial pressures, right? Partial pressures were kind of easy because what is the formula for doing partial pressures?
P1, P2, P3,
However many gases. So basically the formula is the total pressure for a gas, for a mixture of gases, is just the sum of the pressure of the individual gases, right? So if you know what your total is, and you know what the pressure of gas 1 is, you know what the pressure of gas 2 is, but you don't know the pressure of gas 3, how would you figure it out?
total minus 1 and 2 added together.
Yeah, your total minus your 1 and 2 added together. Whatever's left over is going to be your unknown gas, okay? So partial pressures is pretty easy, okay? Just the sum of the pressures. So now we're going to move on to Boyles' law. Boyles' law, and you're just in part 2 of your packet. In this next video, we're going to talk about Boyles' law. So here we've got 4 different syringes, and we've got different pressures. So we've got a pressure here, 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 and here. And then we've got our volumes. I'm going to kind of zoom in on each one. So the volume for syringe number 1, the bottom of our plunger is right there. So I'm going to say that that's 8.4. I'm going to estimate to the hundredths place. I actually, just to make it easy, I'm just going to keep it right at 8.4. I'm going to say that's where that is. Looking at the next one, I think that's right on 5. Looking at the next volume, I'm going to say that's 3.3. And this last volume, I'm going to say is right, I'm going to say it's right on 2. Now I'm going to go to the data table, and you're going to go ahead and fill in the data table. The data table is right. Look at the syringe. So as my volume is going up, the pressure is going down. Okay, so we have an inverse relationship. My pressure is going down as my volume goes up. Here. And then we're going to go ahead and we're going to, let's take a look at how we would graph our data table. So the first thing is, when you're doing a graph for me, make sure, number 1, it takes up all the space on your graph. Do not do one of these graphs that's got the stuff right down here in the very corner. I will not mark it correct. I will just mark it wrong. So number 1, make sure it's got all the space. Number 2, make sure that your axes are numbered correctly. So let's take a look at numbering correctly. I'm going to do the volume first. So I'm going to start with 0 there. So the highest volume I've got is 8.4. So I would not want to have this top number here be a large number, because all my information is going to get scrunched in the bottom then. But I don't want to have 8.4 be the very top. So I'm going to say 10 seems like a pretty appropriate way. There are 20 squares here, so if I divide 10 by 20, that means that I could go up by 2. Or 20 by 10 is what I should have said. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now for pressure, when I'm looking at that, the highest pressure I've got is 3.88. So I definitely don't want to have something that's as high on my x-axis as like 10. I'm going to go for 5. Okay? So there are 20 squares. 20 divided by 5 will give me 0.5. Or the other way around. So 0.5, this would be a 1, 1.5, 2.5. Whoops, I did something goofy here. There we go. I did the wrong number. Back up. I can erase this very nicely. I'm going to zoom in so I can actually see my lines better. So 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. There we go. Now I'm just going to plot my data, and I'm going to grab a different color here. So my first one, my pressure was 1.09, and my volume was 8.4. So there's my first dot. And I need to move that over. About there. My second one, my volume was 5, and my pressure was about 7.7, right around in there. So we want to go with pressure of 7.7 and volume about 5, right there. The next one, the volume was 3.3, and my pressure was 2.52, right about here. And then the last one, my volume was 2, and my pressure was 3.88. And I am not able to talk and do this at the same time, obviously, because I just graphed that in the wrong spot. 3.3. That's why we do chemistry with erasers. Okay, 2 and 3.8, right about there. So now I'm going to connect my dots. And I've got a curved line, and that's what I'm looking for here, and I should have hit this point too. I'm struggling this morning. There you go. So now, based on this graph, describe the relationship of the pressure and volume. So, looking at your graph, as pressure of the gas increases, the volume of the gas does what? Answer those two questions, and then this syringe, solve that mathematically. Move on to the next one. Now, what we saw, this is the Boyles law formula, and it's P1 times V1 is equal to P2 times V2. These little ones, that means the initial condition, or starting condition, or before. The 2's are your final condition, or we could call that ending condition. We could also say this is the new condition, or the after. So these are the words you're going to look at when you're trying to identify these. So let's take a look and see how we would do this in a formula. The first thing we have to do is we have to make sure that we're getting the correct variables. That tends to be the problem that most people have when you're doing gas law problems, is actually pulling out what these variables are. Well, I like to start with the unknown first. So I read my question. If I have 5.6 liters of gas in a piston at a pressure of 1.5 atmospheres and compress the gas until its volume is 4.8 liters, what will the new pressure inside the piston be? There's my unknown. It's the new pressure. So that has to be my P2. So I'm going to put a question mark there. So now I'm going to look to see, well, if that's my P2, I'm going to look for C, what is my V2, my ending volume. So here I am starting with a volume of 5.6. We compress it till the volume is this. So that has to be my ending volume. Now I'm going to go for my starting ones. That becomes pretty easy. The pressure unit in these two numbers is atmospheres. The volume unit is liters, so it's 5.6 liters. You go ahead and do the next two. All right, so it may be a while since you guys have done any kind of algebra. And so I'm just going to walk you through a little bit of how to rearrange these, because you have to rearrange them so that your unknown is isolated. So rearranging these is pretty simple. What I like to do so I don't get things mixed up is this is my unknown, so I put a little question mark above it. Then I go to my formula and I say that is my unknown. Anything that's next to the unknown, I'm going to slide it underneath the other side of the formula. So when I rearrange this, it's going to be V1 is equal to P2 times V2 over P1. I just slid this right underneath. It doesn't matter which side of the equation I'm on. If this is my unknown, put a little question mark there. When I rearrange this, this is going to get slid underneath. So P1 times V1 divided by V2 is equal to P2. And then you go ahead and do the next one. When we're doing a problem with this, again, we're going to go ahead and we're going to pull the variables out that we need. So you've got a 48.0 milliliter container, has a pressure of 420 kPa. What is the volume? Oh, there we go. When the pressure is 105 kPa. So my volume, I'm going to say this is volume 2. There's my unknown. Well, the pressure that goes with that is 101.5 kPa. Now, the other two numbers that are left, we've got milliliters and we've got kPa. Well, kPa is a pressure. And if you're looking for your pressure units, you can look on your reference table in that standard pressure units, and you'll see all the different pressure units that we would use. Our volume is going to be 48.0 milliliters. So now I'm going to rearrange my formula. My unknown is V2. So I'm going to slide P2 under. So this becomes P1 times V1 divided by P2 is equal to V2. Now I'm just going to substitute my numbers in. So on the top here, my P1 was 420 kPa. I'm going to multiply that by my V1, which was 48.0 milliliters. P2 was on the bottom, 105 kPa. Now notice that your units are canceling out here. The only unit I'm left with is milliliters, so that's going to be the unit that I'll have in my answer. When I put this in the calculator, I get 192. Now I have to look at my significant figures, and I need to look at all three of these to determine how many significant figures I need. So this number here has 2 significant figures. This one has 3, and this one has 3. So 2 is going to be what I need for my answer. So I need to come back down to my answer and round this so it has 2 significant figures. With this rounds to 190, and now my unit is milliliters because that's the one I had left. You're going to go ahead and you're going to solve the next few. And you're going to stop here, and you're going to get the handout that's called Boyles' Law and complete that one-page sheet which is attached to the Google assignment.